Okay, so hi guys, welcome back to my channel. So this is going to be the second video of this behavioral design patterns. The first one, command pattern, which I have already uploaded, you all can go and watch that pattern. Okay, so in this video is going to be a bit short. Why? Because chain of responsibility is not a very big design pattern. Okay, although yet it is important, but it's not very vast. Okay, I'll explain you the concept, the main crux of this chain of responsibility, why it is introduced, and what is the main agenda of the using this chain of responsibility, and in which domains it is getting used. And I'll be showing you one code example, and then we'll wrap up. Okay, so we'll start with the definition. So it is a behavioral design pattern that allows a request to pass through a chain of handlers. Okay, so in this pattern we'll be having a list of handlers. Okay, list of handlers, and we'll be having one request. Okay, then this request should be passed from list of handlers, and it will be checked that which handler is capable of handling this request. If that handler is capable of handling this request, then this message get processed inside that handler and will be getting the output. Okay, let's move forward. Okay, so each handler receives the request, decides whether it can process it. If it can, it handles it, otherwise it forwards the request to the next handler in the chain. Okay, we'll be having the chain of handlers, this handlers and then handler 2. Okay, so similar to this, we'll be having the chain of handlers which will be getting a chance to process the request one by one. Okay, so why it is even introduced? So the main and the foremost agenda of introducing this chain of responsibility is to get rid of this if else if pattern. Okay, this is a very cumbersome process when you hard code the logic inside the if else if chain. So to get rid of this, chain of responsibility is introduced. So as you all can see here, this is the request, and these are some handlers which are waiting for the request so that they can process it. Okay, there are two types. Okay, there are two types or two possible flows. So stop at first handler. Okay, whenever the first handler came, okay, so whenever the first request came, if any one handler is able to process that request, at that time only will make the request get processed and will return it. Okay, simply will return. Okay, and if we want every handler to process that request, this is what we are going to use, which is the second pattern of this chain of responsibility. So there are two types. So first type is we want only the first handler to process the request, and we want every handler to process those requests. So you all can see here, handle first, okay, then we'll stop. And in this example, we are telling each and every handler to process this request. Okay, so I hope this is clear. Okay, so these are some drawbacks. These are some drawbacks of not using this chain of responsibility and using that if else chains. Okay, so the first drawback is huge if else chain, tight coupling, violates open close principle. Why this? Because every time this new request came, let's say this is the handler 1, this is the handler 2, and if there is any new handler which is handler 3 is getting introduced, then you need to change this part of code. Okay, so it will violate the open close principle. If you haven't watched the solid principles, please go and watch. I have uploaded that too. Okay, then you will get a clear picture of all the OOPS concepts and the solid principles, which is the base of this LLD patterns. Okay, so moving forward, what are all components that we are going to use in order to implement the chain of responsibility? The first pattern or the first component is the handler. Okay, this is the main interface. Usually what we follow is, inside that interface we write each and every method that is related to that interface only. Okay, so in that handler we have introduced one void handle. Okay, now this is the concrete handler, actual processors. So whatever handlers that we are going to create, it will implement this handler interface. Okay, I hope this is clear till now. And at last we are having the client code which will call the handlers. Okay, so we'll have one example that is enough to understand this pattern, and then we'll move to some real industry users and the benefits, and then we'll wrap up. Okay, so the code example that I have picked is ATM dispensing machine. Okay, so this ATM has 2000 notes, 1000 notes and 500 rupee notes. What will happen? We'll pass the amount 3700. Okay, and we want it to be converted to some notes of 2000. Okay, some notes of 1000. Okay, and some notes of 500. So let's see how we can solve this problem using this chain of responsibility. So let's start from here. So the first part of the component is handlers. Okay, which should be an interface. Okay, but here it is an abstract class. Why abstract class? Because if you'll remember, as I have already recorded this playlist of solid principle, you all can go and watch and have a clear picture of what is the difference between interface and what is the difference between abstract classes, where to use which one. Okay, so let me give you a small glimpse of like why we have used abstract classes. So as you all know that interface can only have the declaration, means declaration of methods. Okay, the remaining classes which will implement that interface will have the initialization, or will say we can override that method and give this specific logic according to that class. Okay, but if we want some default methods which will be applicable to all the classes, then in that case we'll use the abstract classes. The same we are doing here. Why we have used abstract classes, you will soon get to know as we'll go on with the flow. Okay, so this is the next which we have declared. This part of the code is responsible for the handlers to get chained. Okay, as we want to move from one handler to another handler, so this is the part that is responsible for chaining the handlers. Okay, and here is one abstract void dispense. Okay, abstract classes can have both default methods also and normal methods also. So now we'll see how many handlers we have. So this is the handler 1. Okay, this is the handler 2, and this is the handler 3. Okay, now we'll move to the client code. Okay, so in the client code, if you'll see money handler 2000, money handler 500, money handler 100, we have 2000 handler, 500 handler and 100 handler. What we have done, we have started from H2000 and set next as H500. Okay, 2000 handler has set next as H500. This is the default method that will be present in each and every handlers. Okay, so for this example, we have next is equals to 500. Okay, now H500 has set next is equals to H100. So H500 has next is equals to set 100 handler. Okay, and then what we are doing, H2000 dot dispense 3700. H2000, what is the type of 2000? Is 2000 handler. We'll move to 2000 handler. The amount is 3700. Okay, notes is equals to 3700 divided by 2000, which is nothing but is equal to 1. Remainder is equals to 3700 modulo 2000, which is nothing but is equals to 1700. And we are printing the notes as note is equals to 1. We have printed it. 2000 note is equals to 1. Okay, moving to next part, which is remainder. If remainder is not equal to 0, means we can still break it further. Okay, then we are checking that if next is not equal to null, next is not equal to null. Why? Because we have done set next is equal to H500. Okay, here we have 500 handler. Then we'll simply 500 handler dot dispense remainder, which is 1700, will call. Okay, so 500 handler dot dispense, which is nothing but is equals to 1700. So 1700 by 500, which is equals to 3, and the remainder is equals to 200. Notes is greater than 0, yes, so we'll print 3. So 500 notes, we have 3 notes. Okay, remainder is not equal to null, we have 200 as a remainder. Next is not equal to null, we have next is equals to 100 handler. Okay, so what we'll do, 100 handler dot dispense, the remainder amount is 200. Okay, now we'll move to 100 handler. Inside that 100 handler, dispense amount is 200. Okay, notes is equals to amount divided by 100, which is nothing but is equals to 2. If notes is greater than 2, greater than 0, then we'll print 2. As you can see here. So 2000 note is 1, 500 note is 3, 100 note is 2, and the total amount is 3700. So this is the way the ATM machine breaks the amount and give you the respective notes. Okay, so I hope you understood how this chain of responsibility pattern is working. Okay, and what are all components that we have used in order to implement this chain of responsibility. And we can see there are 2 real world usage. The first usage is Spring security filter chain. In this filter chain, okay, through every filter chain the request has to be passed. Okay, if you'll have worked with Spring security, you'll get to know that the request should be passed from authentication filter, then from JWT filter, then from authorization filter, then from exception filter. Okay, so this is the second type of this chain of responsibility. Similar with the API gateway, rate limiter, authentication, authorization, request validation, routing. So this is the chain of responsibility or chain of handlers that is getting implemented in the API gateway, and we are leveraging it. Okay, so the whole point is the inner implementation of these patterns is also using this chain of responsibility. What are the benefits of this pattern? Okay, so the benefit is loose coupling. Sender does not know actual receiver, okay? Sender does not even care about the actual receiver. And the open close principle, adding a new handlers without modifying the old code. This is the main reason why we are using each and every patterns, okay? Modifying code should not hinder the existing code, okay? Chain of single responsibility principle is also intact. Why? Because every handler has its specific logic, okay? So the logics is getting segregated, okay? Segregated, and each and every handler is getting the responsibility of doing their own logic, okay? Now the one variation is it is used when one handler should process the request. So in every request, what we'll do, handle the request, will handle the request, if it can handle or not, will handle the request and will return, okay? We don't want other handlers to handle the request if once it is getting processed, it gets processed by the first handler, okay? The variant 2 is every handler participants used heavily in Spring Boot and web filters. Why I have told? So every filter is handling this request, okay? Now you will see log request, okay? Request, log request, and we are checking this null. If next is not equal to null, then we are passing the request to the next handler. The similar thing that we have used in this example, okay? This is the second type of chain of responsibility. So I hope the pattern is clear, okay? If you'll get a problem statement that is demanding of chain of responsibility, you will be able to implement it. So this is all for this video. Next we'll be covering either the strategy pattern or the observer pattern. So thank you for watching and having patience. So thank you.